General relativity defines the speed of light, c, as the absolute speed limit for all matter and information in the universe. For anything with mass, reaching the speed of light is physically impossible. As velocity increases, the energy required to accelerate further grows toward infinity. The speed of light is not just a speed limit for particles, it is the speed of causality. Traveling faster than light would mean arriving before the cause occurs, violating the fundamental structure of our timeline. Exceeding this limit would fundamentally break our current understanding of physics. FTL is not just difficult, it is prohibited by the very geometry of the universe. In 1994, physicist Miguel Alcubierre proposed a revolutionary way to travel faster than light without technically accelerating. The concept relies on creating a warp bubble. The ship remains stationary inside a local flat space bubble. Because the ship doesn't move through space, it avoids the infinite energy requirement of standard acceleration. The Alcubierre metric works by contracting spacetime in front of the bubble and expanding it behind. The ship effectively surfs on a wave of warped spacetime. However, this classic model historically requires negative energy to function. Since negative energy has never been observed in nature, the practical construction of this drive remains purely theoretical. The Alcubierre drive challenges us to rethink interstellar travel. Instead of building a faster engine, we must learn to manipulate the fabric of space itself. In 2021, a theoretical breakthrough shifted our approach to warp drives. Eric Lentz proposed a new class of solutions called solitons. Historically, warp models required negative energy, which has never been observed. Solitons offer a path using only positive energy density. These are localized, stable waves of spacetime curvature. Mathematically, they allow a ship to ride a wave of spacetime rather than pushing through it. While solitons move us closer to physical possibility, the energy required to generate these bubbles remains astronomically high. This research bridges the gap between science fiction and spacetime engineering, shifting our focus from engines to geometry. Even with the most efficient theoretical warp models, shifting the fabric of spacetime requires energy densities that defy our current imagination. To warp a bubble large enough for a starship, you would need to convert the entire mass of a gas giant like Jupiter into pure energy. This requirement limits FTL to the realm of Type 2 or Type 3 civilizations on the Kardashev scale, far beyond our current capabilities as a planetary species. In short, FTL is currently a mathematical possibility, but an engineering impossibility for humanity. In physics, light speed defines the causal limit. Every point has a light cone representing all future events that can be influenced by that location. Because relativity links space and time, moving faster than light is mathematically equivalent to rotating your trajectory until it points backward in time for certain observers. This creates the grandfather paradox, a logic loop where your arrival in the past could prevent the very events that lead to your departure. Stephen Hawking proposed the chronology protection conjecture. It suggests that whenever a time travel loop begins to form, physics creates extreme fluctuations to destroy it before it closes. While building an actual warp drive is beyond current energy constraints, scientists are using metamaterials to study spacetime engineering in the laboratory. Metamaterials are synthetic structures designed to influence wave behavior. By rotating microscopic elements, we can force light to bend in ways that mimic gravitational distortions. Researchers like Dr. Harold Sonny White focus on detecting microscopic warp signatures. These experiments test effective metrics, helping us understand how to manipulate spacetime fabric. The future of interstellar travel is shifting from speculative fiction to a rigorous study of geometry. While FTL remains physically prohibited by causality and energy limits, modern physics treats space as a malleable fabric. We are investigating whether space and time are fundamental or if they are emergent properties that we might one day edit. Interstellar travel is a goal for civilizations far more advanced than ours. The journey ahead is a quest to map the very foundation of reality.